working with polynomial and power functions, one thing you want to be comfortable doing is talking about end behavior. When we're dealing with polynomial functions, we know that that's a function that has multiple terms with a highest exponent degree, and then it just goes in descending degree order. That's also referred to as a power function because you have x to the nth power, and in for n we plug in some particular value of concern. So we can talk about the direction of these graphs without even graphing them, maybe not knowing a whole lot about it. Maybe I know I'm dealing with a polynomial function and its highest degree is x to the 10th power. I can start to make assumptions about its direction using something called the leading coefficient test. So the leading coefficient test breaks things down based off of if your n, which is your exponent, is odd, or if your exponent is even. So I always tell people that when they write out the leading coefficient test, and I'm going to just use kind of some freehand notation here. So leading coefficient test. The way that you break this down is I say, okay, I am either going to be an even highest degree power or an odd highest degree power. So that's the first direction I go. And then under even, I can be a positive leading coefficient or a negative leading coefficient. And under odd, I can either be a positive leading coefficient or a negative leading coefficient. And so if you look at these images here, it's showing me that kind of what is going on here with an odd coefficient, that one side always tends to go up while the other side tends to go down, and then it's reversed on the other side where the left is now going up and the bottom is going down. So before I really talk about this particular example, I always tell people, don't memorize this, but think about functions that are familiar to you. So if I know that I am focused on the degree, x squared is a familiar function to you. And if I'm thinking about odd, x to the third power is a familiar function to you. And what I'm trying to say with the leading coefficient test is that anything with an even degree power is going to share these common characteristics. So whether I'm talking x to the 4th, x to the 6th, x to the 8th, x to the 10th, x to the 100th, I may not know about that specific graph, but this column right here is going to help tell me about its end behavior just because the degree is even. Now, if I think about a positive leading coefficient, that's like a positive x squared versus a negative leading coefficient would be like a negative x squared. The graph of x squared is a parabola where both sides go up. So that lets me know, and I'm just freehanding saying both up. You can, say left up, right up, however you want to word that is fine. You just want to have the idea that both sides are going up. That x to the 4th, x to the 10th, x to the 100th, x to the millionth, because those are all even degrees with a positive leading coefficient, a positive one in front, all of those graphs' end behavior, the left and the right, are both going up. Whereas with the negative x squared, that would be a parabola that's been reflected across my x-axis, so both sides are going down. So whether I'm talking negative x to the 4th, negative x to the 6th, negative x to the 10th, negative x to the 100th, because they are an even high degree and they have a negative leading coefficient, I know that both sides are going down. Now, moving on to the other side. Now let's think about odd. So a positive leading coefficient would be like x to the 3rd power, where negative leading coefficient would be like negative x to the 3rd power. So what I'm about to say is going to be true for all polynomial functions with a highest odd degree. So I know that the cubic function has the right-hand side go up and the left side go down. Right up, left down. So that means that whether I'm talking x to the 5th, x to the 7th, x to the 13th, they're all positive leading coefficients with odd degree powers. All of their end behaviors will go up on the right and down on the left. Whereas with negative x cubed, there has been a reflection on the x-axis so that now the left goes up and the right goes down. So again, whether I'm talking negative 10x to the 7th power or negative 12x to the 13th power, all of those have negative leading coefficients and an odd degree, so I know their end behavior goes up on the left and down on the right. And again, I want you to notice how I said that. I specifically said negative 12x to the 13th because I wanted you to see that we're not concentrated on is the leading coefficient odd or even. We don't care. We're looking at, oh, this thing is negative. And then we're looking at this degree and we're saying, oh, that thing is odd. So because it's odd, and because its leading coefficient is negative, I know its end behavior goes up on the left, and I know it goes down on the right. Okay, and so these graphs here, if you want to pause your video, that's what these are showing you, is that when you have an odd degree, you're going opposite ways depending on if your leading coefficient is positive or negative. But if your degree is even, depending on your leading coefficient being positive or negative, they go in the same direction. And looking at these graphs, I want to make sure you understand the language and the notation. So when I write things like x arrow infinity or x arrow negative infinity, I'm just saying as x approaches, as it gets nearer and nearer, or it goes out toward infinity or negative infinity. And same thing if I say f of x is approaching infinity or f of x is approaching negative infinity, we know that f of x just represents our y value. Okay, and so this image right here puts everything together for you. If you want to copy this all down, it just summarizes everything that we just talked about. So here are some examples. I encourage you to pause the video, identify their end behavior. So you're going to focus on the highest degree. Is it even or odd? Is the leading coefficient positive or negative? And then determine the end behavior. So in problem number 1, the highest degree is 4. So I'm going to kind of write this step by step for you. So that is an even degree. And then my next step is to focus on my leading coefficient, which is negative 3. So I'm going to write negative leading coefficient. So because it's even with a negative leading coefficient, I know that both sides go down. That is my end behavior. Looking at my second problem, the highest degree is 7, so that is odd. Excuse me, odd. And looking at my leading coefficient, it is positive, so a positive leading coefficient. So because I have an odd degree with a positive leading coefficient, I know that's going to act like x to the 3rd power. So that means my right is going up, my left is going down. And looking at my last problem, the highest degree is 5, so that is odd. And again, I have a positive leading coefficient because my leading coefficient in this case is 12. Therefore, for my end behavior, I know the same thing is happening. The right is going up and the left is going down. Okay. Alrighty, I hope you found this video helpful as always. If you have questions or concerns, please don't hesitate to reach out.